we need to know what each theorem states and how to identify these theorems when we see them in problems. And third, we should know how to show knowledge of circuit theorems in how we answer the questions. And if we can do these three, then we've really got this tricky topic all sorted out. Let's look at the first theorem, circuit theorem 1. And here we have uh, this red line and this red line meeting at A and B, point A and B respectively. Now from point A along this line, we call this part of the circumference the arc AB. So moving from point A, going along the circumference to B, that part of the circumference is called an arc. It's a minor arc. And from A going this direction around here, this is called a major arc. Okay, but what we know is that this angle here is standing on arc AB. This angle right here is standing on arc AB. Okay, this angle up there is also standing on an arc AB. You notice that? Because what we're noticing, we're taking this line as a leg, and this line as a leg, this red line as a leg as well. This angle has two legs, this red line and this red line. Its legs are standing on point A and B. In other words, standing on the arc AB. And this point, this green point here, is the center of the circle. So this angle here is at the center of the circle, while this angle meets where? On the circumference, a point on the circumference. So there's a theorem for that we need to learn. For example, if this angle here is 40, and this angle down there will be 80. So what is that theorem? Is that the angle at the center is twice the angle at the circumference. So even though we have angle as the center as a theorem 1, it's just brief, but we want to add a few words to it. That angle at the center is twice the angle at the circumference. And that's one theorem we want to memorize. There's a lot of words. Angle at the center of a circle is twice the angle at the circumference. We don't have to put this part subtended by the same mark necessarily. Just angle at the center is twice angle at the circumference is sufficient. But we should note that these two angles are standing on the same arc, or we can say subtended by the same arc. Keep this point in mind. Now this rule can be hard to spot at times, especially when the point A and B that we have a little while moved. Okay, so if we go back, notice what we have point A here and point B here. What if I should move point A little bit up here, point B, sorry, and then I move point A a little bit up there as well? Would you be able to spot it? Well, let's look at the other one. Now let's get it. So point A was down here, so move it up there. Point B was down here, so move it up there. Now what has happened is that we have created a new angle by moving those points. Okay, so what we're seeing here is this angle here. Let's move. All right, now if we had drawn a line going across like that, this angle right here would have been 180. Angle on a straight line, 180. But this line has moved further than 180. So from 180 is a straight line. Any more than 180, we call it a reflex angle. So this angle of 230 degrees is what we'll consider to be a reflex angle. It's a reflex angle. Okay, so this reflex angle here, 230 degrees, is at the center still, because we move point B from down here to up there. So now we have point B here, and point A was down here, we move it up there. So that's point A. This is still the angle at the center, and it will still be twice the angle here. So what angle is this right there? It's the angle at the center, and this is still the angle at the circumference. So the same rule applies. What is the answer there? Can you think about it? Let me give you a few minutes to think about it. Not a few minutes, a few seconds, that is. Yeah, that's correct. 115 degrees, a half of the angle at the center. Okay? Must be the center. Now let's see if you can spot this one. Now this angle here, this angle that we have here, is 80 degrees. Okay? If I should ask you, what is this angle here? Would you be able to tell me? Would you be able to tell me what that angle is? Give some time to think about it. So we have this angle right here. Can you tell me what angle is this? Well, this is the angle. If you look at it, it's as if we move point A and B. So this is point A, and this is point B. We have the angle here. So this angle has both legs, leg standing on A, and this leg standing on B. So this is angle 80 degrees. Do we have another angle standing on the same point A and B? Let's check this angle right here. Let's look at its legs. Standing on point A, and let's check its other leg. Right here, standing on point B. So this angle, by the way, this should be at the center, at the circumference. Okay? It's not drawn accurately. So, but the point though is, this angle here, and this should be right here, center. Okay? So this angle here has both legs standing on the same A, same point B, as this angle right here. This angle 80 degrees, A and B. So the angle at the center must be twice the angle at the circumference, because they're both standing on the same arc AB. They are subtended by the same arc. And this is not necessarily easy to spot as mentioned early on. So that's one thing we always have to keep in mind. They're not always easy to spot, but if you focus on the theorems or the principle that is, you're certain to get it. So yes, the angle at the center is 80. The one at the circumference must be 40 degrees. Looks different, but still the center.